So this video is just for you to look at if you got stuck on a question that we were covering in the lesson today, or if the technology went glitchy and you couldn't hear me properly. So these are the questions up the top that we'll go through, and you can obviously just fast forward to the bits that you need help with. Okay, so we would have first gone through the difference between perimeter and area. I hope we all know that perimeter is around the outside, whereas area, it's how many units are filled inside, like you're tiling something. And we need to make sure that there is a difference between 1 centimeter, right, which would be just approximately like that. I'm just doing it approximating, whereas 1 centimeter squared, right, becomes that thing there. So when you're putting your units, it's really important that you make sure that if you're talking about area, you put the squared. If you're talking about just perimeter, the distance around something, it's not squared. Okay, and obviously later on we're going to look at volume, where we would be going units, yep, cubed. Okay, so that's for a little bit later, and we're just going to be recapping all of our perimeter and area stuff. So do make sure that you've got your formulas handy here. It's not about memorizing at the moment, although most of you probably remember some of these ones, but make sure you've got that on hand, whether you've printed it out or you can just flick to this page somewhere in iBooks, whatever, but make sure it's at hand. Okay, so when we do a problem, it's pretty simple. If you follow this routine every time, you're going to be fine. And this works for a variety of maths questions, not just area. So first thing you're going to do is, I guess we shouldn't say write the formula, but it should actually be choose which formula that you're going to need. Now, obviously, I think we know if it's a rectangle / square, that's going to be length times width. So make sure that you write that formula down, and then you choose your information. Some of you would have written L times L or L squared, because with a square, they're the same lengths. Okay, and it just now becomes a calculator job. Whack that in your calculator, away you go. And then, yes, we've got our area ones for this one. Same thing, write your area formula down. We know that this is our length, this is our width, or you could have put it the other way around, it doesn't really matter. Pop those in and away we go. So if you just follow these steps, all right, 1, 2, 3, make sure they're done. I check my units, all good. I think you'll be fine every single time. All right, onto the triangle ones. And again, you refresh your memory. What have we got for the triangle? A half base times height. You've noticed I don't write that whole thing down, B and H. I would say this is the one that causes a couple of errors from students. So just make sure that when we're talking about this, your base is a flat one there, but the height, it's not that, right? It's your vertical height, the one that goes there, right? So when we come back over here, first thing we will do, so if we're looking at E, we will say, let's write our formula, a half base times height. Okay, we've established that this one is our base, and then our vertical height is the 6. You don't have to do anything else, okay? But just make sure that you use your vertical. Sometimes I might be a little bit sneaky, and I might maybe say, oh, let's give them some more information. I'm going to say that that's 8. So that's me checking when you put in your information, you don't just go, oh, I'll just pick any 2 numbers. Make sure that it is the base and the vertical height, right? So we've got that right angle there. So it would have to be 3 times 6. Okay, 3 6s, 18 times a half, which is the same as dividing by 2. So we've got 9 centimeters squared. All right. Sure, you can do F by yourself. Right, same thing, pop your formula, put your information in. That's my B. This is my vertical height. Pop it in, hit your calculator, and away you go. So really, the rest of these questions, it's all about matchy-matchy. So we look, we see that this is a parallelogram, right? So when we go to our formulas, right, what shape? Clearly, it looks like this one, your parallelogram. What does the formula say? Base, again, It's this vertical height here. So then we look at our diagram. Have we got the base? Yes, we do. And have we got the vertical height? Absolutely. Okay, so our base is 12, height is 10. I've written my formula, and then it's just a simple matter of substituting my information in. Okay, and I think H is again pretty similar. They're being nice and they're going shape by shape. Obviously, when they're mixed up, you can just go and look. All right, on to a kite or diamond. So you don't have to memorize and think, what was it? What was it? You look over here, okay? So we're going to put the half. So we'll write that down. So area is a half. And then we have to look at what the other bits are. So X. What is our X? Well, you can see X is all the way from one vertice. Okay, that's what these little things here are called. Vertex, vertice, one to the other, straight across. So we look, and I better just write that formula there. Now, was it X times Y or was it X plus Y? Don't make it up. Don't guess. Go back, check. Okay, so we write that. And what is our X from one all the way across to the other? So we know that X is 10. And then the Y, what is that? From the other vertical one. And so our Y, you can see very nicely here, is 7. So again, you just write it down. That's a half. In between the half and the bracket is a times. X is 10. And following along, it's telling me what to do. It says times. I put times. Pop the 7. Done. All that's left for you to do now is work it out. Hopefully you don't need a calculator. Okay. You could go, I don't need the brackets because it's all times. So a half times 10 is 5, and 5 sevens are 35. For those of you out there going, go do the brackets first, or when it's all multiply, it doesn't matter. But notice 10 sevens are 70 times a half, or timesing a half, same as dividing by 2, and we get 35 as well. So it doesn't matter. Okay. This one is just rotated, or it's more vertical than horizontal, but same thing, right? From one side to the other. Okay, that can be, we could say our X is 25. I mean, or you could have said Y, doesn't matter. The only thing you've got to be careful of here is when you see that 8, that's not all the way across, it's only half. So that would mean the other value, instead of being 8, it's going to be 16. Now, if you looked at that and you said that Y was 25 and X was 16, it's the same thing. It doesn't matter. Okay, so we pop that in here. It's a half. Writing my formula. I know it's annoying, but you get used to it, and it just becomes habit, and it reduces any potential for silly errors. Okay, and bang, away you go. Next. Again, we look, what shape does that look like? We've got 2 parallel sides. You probably all know this one. That's and it's nice, it's the next formula that they go through. So it's your trapezium, or trapezia. I like to say trapezium. So we write our formula A plus B divided by 2, and what are A and B? They are your 2 parallel sides. And then we times that by the height. So write this down. We're going to go A equals, I better write it like they do. I used to write it a little bit differently, but that's okay. Times the height. And remember, A and B were your 2 parallel sides, so that's clearly this one and this one. It doesn't matter which one you call A and which one you call B. So we're saying that equals A, that equals B, and this is clearly your height. So now we substitute. So instead of writing A, what did we say A was? We put 11.2. It says plus, right? There's a plus here. I put plus. B, which is 12.8. Right? Not much thinking. I'm just following. Okay? The formula said over or divide by 2. So I say over and divide by 2. What comes next? Times height. Our height is 6. And now it's all down to your calculator. Okay? That's it. hopefully you know how to use your calculator. Now, my one looks a little bit fancy, but it works, and it should have things in roughly the same position as yours. My fraction button, I don't know if you can see if I put the pen here, but it's that one there I'm pushing. There you go. Pushed a few too many times. Yours is in the same spot, just a little bit further up with your calculator. So hopefully you can find your fraction button, and we just type in what we see. So we're going to push our fraction first. We'll put your brackets, right, fraction, and it was 11.2 plus 12.8, so 11.2 plus 12.8. Use your arrow key. Yours is in the middle of your calculator, mine is to the side here, and then times by, and it was 6. Press enter. Right, so 72, and don't forget the unit squared. Okay, and last but not least, we've got this one. Now all they've done is they've turned it around. Okay, so you can see your parallel sides are now this one and this one. So that means your A is 7, your B is 5, and this time your vertical height is that one. So your height is 6, and we're going to substitute in just like we did before. So write your formula A plus B, and think about it as you're writing it. It's the two parallels, or the average of the two parallel sides. So A plus B divided by 2 times the distance between the two parallel sides. Okay, and 7 plus 5 over 2. And again, doesn't matter if you put these two around the other way. Your A could have been 5, your B could have been 7. But it does matter. You have to make sure that you get the right H value, so the distance between the two parallels. Okay, times 6, and again, off you go. Go your calculator, and we're done. As long as you remember unit squared. So hopefully this is registering and it's all good. Okay, we now look this time. Okay, now we're trying to find what is the area of a circle. Do you remember the formula for area of a circle? If you don't, go to your formula page, and there she blows. Okay, so we're writing it down, and again, I hope we remember that when we are writing pi, that's that 3.14, etc., and it's times, that's in between, times r squared. So we know there's nothing there in between, but we know it's actually a times, and we know that squaring means timesing it by itself. So your only dilemma is looking at this and knowing the difference between radius and diameter. So this is our radius right here. The diameter goes all the way across. Okay, so all the way there. In this case, our diameter would have been 6. But lucky for us, they've told us our radius is 3. So we pop that in, pi times, instead of r squared, our r is 3, so we say 3 squared. How do we pop that in our calculator? Now, my pi button, you can see on mine, if you look right down the bottom, again, I don't know if you can see when I'm touching the screen there. If I just touch that, you can see on the screen it becomes times 10 to the, because the pi is in the yellow. So to get that, I have to say shift pi. Your pi button is also in the similar spot on your calculator, okay? So times, and we're going to say 3, and you look upstairs, my squared button, I just pressed it then, is here. So you see squared, and it pops up. Or you could just say 3 times 3. Now again, mine is a little bit fancy. It comes up as 9 pi, but yours will come up as 28.274. Now we're going to go 2 decimal places. So it means I have to look at the 3rd decimal place there. So we'll do that, 28.274. So you don't have to write this line here, 28.274. If I want 2 decimal places, better read, 1 decimal place. So what I have to do means I have to look at the 2nd decimal, and because this number is a 5 or more, that means it becomes 28 point rounds up 1 to 3, and we say centimeters squared. Okay. that's about it for that one, really. Part B, they've tried to be tricky, and instead of giving you the radius, that's not the radius. What is that? That is the diameter. So if the diameter all the way across is 10, that means the radius is halfway, which will be 5. So you're going to do exactly the same that you did in A, but this time, instead of saying 3 squared, it will be 5 squared. Huzzah! Hit your calculator, see how we're going. I think C is pretty much the same. Carrying on. Woohoo! We've got pieces of pie. These are called sectors. Again, our classic formulas, our formula page is going to help us. Hope we remember. Basically, this is just a fraction of a circle. So why have we got this here? Well, how many degrees are in a circle? 360 all the way around. And we're saying how much of that circle have we got? So that's saying how many degrees out of that sector do we have? We're going to find that fraction of the area of a whole circle. So let's put that into practice. Come back here. We're going to say area equals, I like to write the area formula of a circle first, and I times that by the fraction of the circle that we have. So what 2 bits of information do we need? We need the radius. Well, tick, we've got that. It's 5. And this symbol, funny symbol here, that's theta. That stands for the angle. So that is my theta right there. It's my 35. So here we go. We're saying pi times r squared. So that's going to be 5 squared. What does it say to do next? Times. And now I'm going to put the theta, which we've already said is 35, all over, right? Just following the formula, over 360. And now it's all down to the calculator. So back to our trusty calculator, I'm going to say shift pi times the radius squared. Look at my memory, I forgot that, 5. So 5 squared times, I can pop my fraction in, 35 over 360 equals, again mine does fancy pants. Okay, let's just check how many decimal places do we want. Again it says 1, so 7, 6, I'm going to write 7, 6, 3, but it said I only want 1 decimal place, so I'm looking at the second decimal, and because it's less than 5, I leave it as 7.6 centimeters, and don't forget the squared. You don't need to write this bit, I'm just doing that to show you. Okay? And it's the same thing. This is another sector of a circle. So you write your formula. Should be becoming routine now, right? What information do I need? Well, we need the radius. Look at your diagram. Do you have the radius from the center all the way to the outside? So yes, our radius is 6. Do we have how big, how many degrees our sector is? Yes, we do. That's your 124. That's your theta. So again, in we go, pop in our radius, 124. Huzzah. Okay. And I'll leave you to do F by yourself. So hopefully, if you got stuck, that's sorted out any issues you may have had.